Okay, here is another magical object I share on my channel. I've recently posted a video that talks about rattlebacks. And these are objects that are self-reversing when you spin them, seemingly to defy the laws of physics. Okay? Now this one also involves the laws of physics supposedly being violated when in fact the laws of physics sometimes are seemingly magical in nature. So this is called Newton's nightmare, and it says suspend the law of gravity. Okay, so it's sold as a magic trick. And the way I've used it in the classroom is I've bought two of these, two sets, so that I have one that a student holds, I have them come to the front of the class, and then one that I hold. Okay, and I claim that over the years I've developed such a magnetic personality that I can affect the force of gravity itself. Okay, so let me show you what happens for the student. So the student, maybe I'll move this one out of the way for now. Okay, and maybe I'll hold it this way here. So this is the students, and so they're standing just a few feet away from me, holding it upright, and then you can see that there's this kind of shiny cylindrical object here. Okay, and it fits inside the hole here. And then you can see that it has holes drilled into it so that we can watch this object falling. Okay, the students here, I'm over here with mine. We hold our respective little cylindrical objects at the top, and then on the count of 3 we let these things fall. So we're interested to see if I'm able to slow the fall of mine. So when the student drops theirs, 1, 2, 3, it almost immediately, in less than a second actually, it falls through the tube and they catch it in their other hand. Okay, so, and that's what you would expect it to do, right? That's really what you would expect it to do. And then I'm standing over here with the same kind of tube, same looking object here. Okay, and so now when I say, now on the count of 3, watch what happens. Okay, so 1, 2, 3. I don't know if you counted that. It's close to 5 seconds. 1, 2, 3. For it to fall through the tube. Whereas the students falls through in less than a second. So to turn it into an experiment to test whether I have this remarkable property, what we do is we switch our objects. Okay, I supposedly take this one now as mine, switch it with the one I used. Okay, now in my hand I'm not doing that. I'm actually just giving them the same metal object back. And we try it again, same result. And then we even switch our tubes. So their tube is now used by me, and my tube goes to the student. Okay, and then we try it again with these two objects and having them switch as well. And every single time the students falls through in less than a second, and mine takes close to 5 seconds. And why don't we just show that one more time here. So this is the students. They go like this and go. In fact, you can't even really see it falling. Okay, it just falls so fast. Okay, and then this one, it's almost like it's on an elevator, just gently going down. Okay, well, what's going on? This is an aluminum tube, and aluminum is a conductive metal, okay? Just like copper is. And when you have a strong, this is a neodymium rare earth magnet, very strong magnet. If you have a magnet moving within a conductive material like this, it induces an electrical current, and the corresponding magnetic field for that electrical current opposes the magnetic field of the object that's falling itself. So essentially it just slows its descent. Okay, so when you drop it, it looks like it's going down, like I said, in an elevator. Okay, so it's because this is magnetic and this is conductive as an aluminum tube. Whereas the other little object, it looks identical. They both come in the package there. But this is brass, and brass is not inherently magnetic. Okay, and so when you drop this, it will just drop through as you would expect it to. Okay, so Lenz's law, the more formal statement is the direction of an induced current in a circuit is such that it opposes the change in magnetic flux that produced it. In simpler terms, the induced current creates a magnetic field that opposes the change in the original magnetic field. This principle is a consequence of the law of conservation of energy. In the packaging, it comes with a few different suggested modes of presentation as a magic trick. What I did with my students, where I bought 2 of them, it's not suggested here within the write-up in the packaging, but that would be one way to do it. But there are simpler ways of presenting it where you only need to purchase one of these to blow people away. So anyway, this is a remarkable property of nature that many people are not aware of, and it's the basis of a number of technologies, whether it be a braking system, or like, let's say, a roller coaster. You're trying to bring it to a stop. Well, you can do it by way of electromagnets and conductive materials that will very comfortably bring that roller coaster to a stop. A similar thing happens for many exercise bikes, the ones that don't have chains or pulleys on them, that are using friction, ordinary friction, as the opposing force as you pedal the exercise bike. What they use instead is a large aluminum disc and then strong neodymium magnets around that. And the closer those are brought to that disc and the faster you try to go on that exercise bike, it creates an ever stronger opposing force that counters your effort to pedal on the exercise bike. So you can actually feel it pushing against you. Well, that's Lenz's law. And a bit more deeply, it involves something called eddy currents. So eddy currents are induced in the aluminum disc, which create a corresponding magnetic field that opposes the magnetic field of the magnets that are closing in on that aluminum disc here. It's a fun physics/math magical phenomenon that really is very surprising and completely inexplicable unless you're aware of Lenz's law, which most people are not. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.